Hi everyone, good morning. We are the Group 5. I am Monica Matthew Alcuavas, together with my group mates Muhammad Alias M. Ali Nasser, Princess Alhamsi Diego, Ashlea Lucas, Alnor Bantilan, and Javar Haji Basit. We'll be discussing the development of mathematics, a historical overview of the modern period, the nature of mathematics, and the issues and aspects. And this is History of Mathematics. So here are the topics that we will be discussing to everyone. A. The development of mathematics, a historical overview of the modern period with its subtopics. A. Non-Euclidean geometries. B. Modern algebra and number theory. C. Birth of set theory and problems in the foundation of mathematics. To be discussed by Alnor Bantilan and Javar Haji Basit, our first reporters. The development of mathematics, a historical overview of the modern period.
Good morning, sir. Good morning, everyone. I am Jabar M. Haji Basit, the first reporter of Group 5. My topic is all about non-Euclidean geometry. Non-Euclidean geometries. Who was Euclid? Sometimes, in the 14th century BCE, a boy was born in Alexandria who would grow up to become one of the most famous mathematicians and thinker who ever lived. His name was Euclid, which in the Greek means renowned as glorious. Euclid was a famous mathematician in his own time, and he only became more famous and influential in the thousands of years that followed. He wrote a book called The Elements, in which he laid out the basic principles of geometry that we still know as used today. His book was the primary textbook used to teach mathematics in the Western world from the time it was once written until the beginning of the 28th century. Even today, much of what is taught in a typical geometry course come from Euclid. What is non-Euclidean geometry? For over 2,000 years, Euclid's 15 postulates remain to the proven from the first four. It wasn't until the 18,000s that a new train of truth arrived. Instead of trying to prove a validity of postulate, poking the first four of assumption. There were mathematicians who look at what happened when it is instead negated. First, it was another famous mathematician, Carl Gauss, who began exploring the geometries that exist when the first four postulates are taken as the core axioms, along with the fifth postulate's negation, but it wasn't until the independent publication of the Russian mathematician Nikolai Novakhev and the Hungarian mathematician Janusz Bolyai in the 1830s that over become aware of the geometry. Euclidean geometry studies curve rather than the flat surface. Although Euclidean geometry is useful in many fields, in some cases non-Euclidean geometry may be more useful. For example, suppose you want to measure the shortest distance between points of the Earth. The surface of the Earth is curved, not flat, a fact that Euclid was not aware of. Of course, techniques from the non-Euclid geometry will be much more useful in this case, science in the Earth of sphere. Who invented non-Euclidean geometry? Was it the Gauss? Was it one of the first two that published work in the field? Or perhaps someone that came long before Gauss and Lobachevsky and Bolyai, whose name will never be known, no matter who truly invented it. credited with coining the terms of non-Euclid geometry. Example of non-Euclidean geometry. One example of non-Euclidean geometry is spherical geometry. Triangles drawn on the surface of a globe will have interior angles that sum to over 180 degrees.
Assalamualaikum warahmatullahi wabarakatuh and good day. My name is Alnor Haji Zainuddin Bantilan and I will gonna explain what is modern algebra or also known as abstract algebra. So, basahin po natin sa screen yung definition. So, abstract algebra is a set of advanced algebra topics that deals with abstract algebraic structure rather than traditional number systems. The most important of these structures are groups, rings, and fields. Commutative algebra, representation theory, and homological algebra are important branches of abstract algebra. Linear algebra, elementary number theory, and discrete number or discrete mathematics are all considered branches of abstract algebra. In his definition of abstract algebra, Ash on 1998 includes the following areas: logic and foundations, counting, elementary number theory, informal set theory, linear algebra, and linear operator theory. So, dun pa lang sa definition, no, basta based on the name alone, maiisip mo na talaga na parang katulad din to ng algebra na karaniwan nating nai-encounter or karaniwan nating napapag-aralan nung tayo ay nasa high school pa. Pero medyo abstract nga lang, no? So, pero kung bubuksan natin or hahanap tayo ng mga libro or magbabasa tayo ng mga libro patungkol sa abstract algebra or modern algebra, mapafind out mo or mabibigla ka na lang na parang hindi to katulad ng algebra na kung saan ito na ating natik nung tayo nasa high school pa lang, no? So, para mas mapadali natin tong maintindihan. So, kailan ba to nagsimula or anong taon to nagsimula? So, the year is 1800. And for some time now, people have known how to solve linear equation, quadratic equation, cubic equation, and even quartic equation. But, ang tanong, paano naman yung mga equation na may higher degree? Like degree 5, 6, 7, and beyond. So, a young teenager named Evariste Galois answered this question. And to do so, he used a tool that he called group. Around this time, or sa panahon na to, si Carl Friedrich Gauss was busy making or abala siya sa paggawa ng kanyang mga own discovery, and he ironed out a new technique called modular arithmetic, which helped him to solve many problems in number theory. So, modular arithmetic shared many similarities to the groups used by Galois. The 1800 also saw a revolution in geometry. For more than 2,000 years, si Euclid dominated the scene with his book The Elements. But mathematicians began to realize that there are other geometries beyond the one devised by the by the one beyond by the ancient Greeks. And it didn't take long before groups were found out to be useful tool in studying these neo-geometries. So, it soon became clear that groups were powerful tool or ito ay makakatulong sa kanila upang maintindihan nila yung mga iba't ibang complex na mga equation. So, it made sense to abstract out the common feature of this tool used by Galois, Gauss, and other into a general tool. And to then learn everything about it, thus group theory was born or ipinanganak yung group theory. So, and if groups were so useful, so it is natural, no? It is natural to ask, would this approach work elsewhere? Soon, New abstract objects began to take shape: rings, fields, vector spaces, and modules. This didn't happen overnight, no? So, di lang to natapos ng isang gabi lang. Mahabang panahon or mahabang proseso bago natapos itong bago nabigyan ito ng mga definitions, no? It took years of hard work to find the right definition. Too specific and they wouldn't be very useful. Too general and they would be kind of boring. So, medyo may pagka-boring. And not very useful, but eventually the right definition were identified. Altogether, the form, the subject we know call about abstract algebra. At first class, sa unang tingin pa lang, no, maiisip mo na talaga na parang hindi naman to applicable itong abstract algebra sa ating mundo, no? So, or sa mundo na ating ginagalawan. But it is a young subject, no? And it is useful, continue. And yung pagiging mahalaga nito is patuloy pa ring dinidiscover. And every year, new uses of abstract algebra are found, and not just makikita mo talaga na hindi lang applicable ang abstract algebra sa mathematics. So physics, chemistry, computer science, and other areas are discovering just as useful abstract algebra can be. So, correction lang natin, no? Quick note. Abstract algebra is sometimes called as modern algebra. So, baka may maguluhan din, may magsabi na ano pa tong modern algebra and ano naman tong abstract algebra. So, isa lang po yun, no? So, ang abstract algebra is tinatawag rin minsan na modern algebra. So, kapag may mga kasama mo naman yung mas magagaling sa mga or magaling sa mathematics, like mathematicians, they also call it as algebra. So, kailan ka magiging ready upang pag-aralan itong abstract algebra? So, ano yung mga dapat nating tandaan? So, first, you really need to know the more familiar algebra or the basics. So, bago mo to aralin, kinakailangan mo talagang pag-aralan yung kung ano ba yung mga basics sa algebra. Like yung mga factoring, kasi applicable din siya sa abstract algebra, special products, pag-solve ng linear equation, quartic equations, cubic equations, and etc. But the most important requirements are these: mathematical experience and mental maturity. Have you seen mathematical proofs before? Are you able to think very abstractly? If so, then get ready or maging handa ka. Abstract algebra will challenge you like never before. So, sa madaling salita, ang abstract algebra is naiiba sa kung anong algebra ang pinag-aralan na or algebra na napag-aralan natin nung tayo na sa high school. Ang focus ng subject na to is these subjects focus on abstract structures with names like groups, rings, field, and modules. These structures have application in many areas of mathematics and are being used more and more to science too. So, ang application nitong abstract mathematics or abstract algebra is hindi lang po sa mathematics, no. Applicable din po siya sa mga iba't ibang field like science, physics, medicines, chemistry, and computer science. So, ganyan po kahalaga, kaimportante itong abstract algebra. So, yung mga cellphone na hinahawakan natin ngayon, pinapasukan rin yan or ginamitan rin po yan ng abstract algebra. Bago nagawa yung mga application na ginagamit natin today, may abstract algebra na ginamitan rin yan ng abstract algebra, and etc. So, isa yan sa mga kahalagahan na dapat nating ma-appreciate na hindi lang na sobra talagang importante ng abstract algebra in terms sa ating daily life. So, hanggang dito na lang. So, ang susunod naman na ating i-explain is ang number theory. So, ang pangalawa naman po nating i-explain is itong number theory. So, basahin na lang po natin sa screen yung itong yung definition nitong number theory. So, number theory is a branch of pure mathematics that studies natural numbers and integers. It is the study of the set of positive whole numbers, also known as the natural numbers. So, saan ba 'to nagsimula 'tong number theory na 'to? So, specifically or way back, uh, nung panahon na di pa nag-i-exist si Jesus is meron ng number theory. Specifically sa panahon ni Euclid of Alexandria, which is he is accredited as the father of geometry. So, sobrang importante nitong number theory na to, no? So, gaya nung sinabi nung German mathematician na si Carl Friedrich Gauss, which is mathematics is the queen of all sciences and the number theory is the queen of mathematics. So, it already means nangangahulugan ito na kung wala ang number theory is hindi magiging kompleto or hindi mabubuo yung mathematics. No, so, sa number theory, it is also known as higher arithmetic. It is essentially mathematical interaction in number types. So, may iba't iba tayong different types of numbers, no? Including na yun dyan yung mga odd numbers, prime numbers, even numbers, and any other sort of types of numbers, no? So, isa-isahin natin to, no? Itong mga types, no? Una na dito yung natural numbers. So, tinatawag din ang natural numbers, tinatawag din itong counting numbers, no? Magsisimula sa 1, 2, 3, 4, and so on and so forth them. Ang whole number naman is kagaya lang din ng natural numbers, ngunit magsisimula ka lang sa 0. Unlike sa natural numbers na magsisimula ka sa 1. Sa whole numbers, magsisimula ka sa 1, 2, hanggang sa positive infinity. So, ang integers naman, it is the set of positive and negative numbers. So, example niyan is negative 1, negative 2, positive 1, positive 2, hanggang sa magsisimula ka sa negative infinity patungo sa positive infinity. So, kasali rin sa mga type of numbers, no, is ang rational numbers. So, ito naman yung these numbers that can be written as a fraction. A over B, where A is a whole number and B is a whole number also. So, halimbawa na lang yan is yung 1 over 2, 2 over 3, 5 over 10, and etc. So, kasali na rin dito sa rational numbers or including din dito sa rational numbers yung mga integers. So, kasali rin sa types of numbers isang irrational numbers. So, ito naman yung mga numbers which are not included in the previous set. So, para mas mapadali natin itong matandaan or ma-memorize, itong mga number is special non-reoccurring decimals. Halimbawa na lang po nito is yung logarithm of e, pi, square root of 3, square root of 5, square root of 2, yung ratio ng golden ratio, and etc. So, ang even numbers din po is kasali rin po sa types of numbers, which is ito yung mga numbers na kung saan pag dinivide mo sa 2 is ang magiging remainder is equal to 0. So, example na lang po niyan is yung 0, 2, 3, 2, 4, 6, 8, 10, and etc. So, sa add naman, it is kabaliktaran nung even numbers, no? Magsisimula ka sa 1, 2, 3 hanggang sa ito yung mga numbers na kapag dinivide mo is may mga remainder, no? So, number theory is sa number theory po is ang purpose ng branch of mathematics na to is to take those numbers, yung mga sinabi nating types of numbers, and ask question mark about their relationship and use a formal mathematical proofs. Magseset ka ng formal proofs to answer those question. So, halimbawa na lang po nun is about 2,000 years ago, no? So, si Euclid look at the group of prime numbers known as primes. So alam naman natin yung mga prime which is divisible lang siya sa 1n ang kanyang self, which is tulad ng 2, 3, 5, 7, and etc. So, and he asked a question on how many primes are there, at ang akala niya is it would be infinite, no? So, ang akala ni Euclid is walang katapusan, no? The more na pumunta ka sa mas maraming number, the more na tumingin ka sa mas maraming number is makikita mo talaga na may makikita ka rin doon na prime numbers. So, then he make a hypothesis and proved it using formal proofs, and he used proofs by contradiction, which is a type of formal mathematical proof in which he made a assumption that they were finite numbers of primes and show why that assumption was wrong. So, we can see and we can say that ang number theory is all about asking question, no? So they were asking question about numbers, no? And sa matagal na panahon, for many times or long time ago, people thought that number theory cannot be applied in real world, and it is just for the people who love math and what to do and want to those ask question about math. But as we enter in the 21st century, we realize that number theory has a lot of real world applications. So one of the tenets of number theory, or isa sa mga kaimportante or kahalagahan ng number theory, is the fundamental theory of arithmetic, which is basically says in essence that all numbers can be factored into a unique set of primes, no? So idagdag ko lang din, no? So sa modern number theory naman, ang tinaguri ang father of modern number theory is si uh, Pierre de Fermat, no? Siya yung kinonsider nila or siya yung inaccredite nila bilang father of modern number theory. So hanggang dito na lang din. Ang isusunod naman natin na itatakal is yung set theory, which is started from, if hindi ako nagkakamali, started from 17th century. So, last na po, no? Dito tayo sa set theory. So, ano ba tong set theory? So, set theory, it is a branch of mathematical logic that studies sets which can be described informally as a collection of objects, although any object can be collected into a set. Set theory as a branch of mathematics is mostly concerned with those that are relevant to mathematics and general. So, may mga nagsasabi na it was first introduced by George Cantor on 18th century. So, set theory as a separate mathematical disciplines begins in the work of Cantor, no? Unang nag-propose nito is si George Cantor. One might say that set theory was born in 1873. May mga tao na nagsasabi na it was born or it was published on 1873, which when he made the amazing discovery that the linear continuum, that is the real line, no, is not countable, meaning that it is point cannot be counted using the natural numbers. So even though the set of natural numbers and set of real numbers are both infinite, there are more real numbers that there are natural numbers, which open the door to the investigation of different sizes of infinity, no? So makikita natin the entry of the early development of set theory for a discussion of the origin of set theoretic ideas and their use by different mathematicians and philosophers before around Cantor's time, no? So it is basically, para mas madali nating maintindihan itong set, it is a collection of it's either things, person, and etc. So marami po, para mas madali nating maintindihan. maaari it's either tao po yung pwede nating sabihin na sa collection of names ng mga tao, collection ng mga things, and etc. no? So, ang question is, papaano na-discover ni George Cantor itong set theory? So, he discovered it by the time of the Congress. However, Cantor had discovered the first of the paradoxes and the theory of sets, no? Na-discover niya yung mga paradoxes na to while working on his survey papers of 1895 and 1897, and he wrote to Hilbert in 1896 explaining the paradox to him. So, between 1874 and 1897, Cantor created a theory of abstract sets of entities and made it into a mathematical discipline. This theory grows out of his investigation of some concrete problems regarding certain types of infinite sets of real numbers. So, pangalawang question is, what is the purpose of set theory? So, set theory is very important, no? Mainly because it serves as a foundation for the rest of mathematics. So, it provides us the action from which the rest of mathematics is built up. So, papaano natin nagagamit ang set theory sa ating real life, no? So, returning to real life examples of sets, no, we can observe that in kitchens, utensils are organized in such a way that plates are kept separate from spoons. Another example is when we go to mobile showrooms, we see that sophisticated phones like Galaxy Duos, Lumia, Oppo, Vivos, and etc. and so on are segregated from plain mobiles, no? So, may mga types tong set, no? In basic set theory. So, nandiyan na yung finite set, which is the number of, which is ang finite set, no? It is the number of element is finite, no? Then, meron ding kasali rin sa type of sets is ang infinite sets, which is the number of elements are infinite. Meron ding empty set or tinatawag na null set, which is ito yung set na walang elements. Meron ding singleton set, it is only kung saan meron siyang iisang element. Then, meron ding equal set, two set, which is dalawang set are equal if they have the same elements. So, hanggang dito na lang po, no? So, hope po may naintindihan kayo. So, maraming salamat po. So, dito na lang.
Problem in the foundation of mathematics. The foundation crisis is a celebrated affair among the mathematicians and has also reached a large non-mathematical audience. A well-trained mathematician is supposed to know something about the viewpoints above. A professional aims to seek the opinion about the topic, either dismissing the foundational discussion or irrelevant. The early foundation of mathematics, historically speaking, logicism, was a need intellectual to the rise of mathematics, and particularly to this theoretical approach to 1871 to algebraic number, his set theoretical definition of number field and ideals, and a method by which he proved the results, such as the fundamental theorem of unique composition. Various new theories constituting the foundation mathematics are presented in the chapter. The type theory is one of the most ingeniously sophisticated systems ever produced. Intuitionism is a second important mathematical theory. Another important theory is Hilbert's proof theory, which provides a powerful method of assuring mathematicians that no new kind of logical anatomy would emerge. The proof theory is suitable for achieving negative about the categoricity and monopurposism of formal systems, the invention of deductive inference, abstractions, and axiomatic method was very fruitful for the development of mathematics. But it tempted mathematicians to regard mathematics as a pure deductive science and to forget that their axioms were originally abstracted from empirical facts and that the rules of deductive inference are valid because they have been tested in the actual thinking practice of mankind. Since virtually every mathematical theory can be interpreted in set theory, the latter is foundation of mathematics. Whether set theory, as opposed to any of its rivals, is the right foundation for mathematics depends on what foundation is for. One purpose is philosophical, to provide a metaphysical basis for mathematics. Another is epistemic, to provide the basis of all mathematical knowledge. Another is to serve mathematics by lending insight into the various fields. Another is to provide an arena for exploring relations and interacting between mathematical fields, their relative strengths, and etc. Given the different goals, there is a little point to determining a single foundation for all of mathematics. Thank you.
Now let's move on to the nature of mathematics.
Good day everyone, I am Ashleia Lucas. So now I will discuss to you the nature of mathematics. The nature of mathematics. It is a numerical and calculation part of human life and knowledge. Mathematics helps in self-evaluation. Mathematics involves the conversion of abstract concepts into the concrete form. Its knowledge is applied in the study of science and its different branches. Examples: physics, chemistry, biology, and etc. In the nature of mathematics, we know that in the nature of mathematics has their own perspective. Like for example, there is a blind of 6 people and all of them have their own position in the elephant. One of them said it was a snake. The number 2 said it is a spear. The third person said it was a fan. The fourth person, 1, he said it's 3. The fifth person said it was a rope, while the other person said it was a wall. Now, let's relate it to mathematics, that these 6 blind people, which means that every person has their own opinion in mathematics, and some of them has a different invention in perspective. The simplest mathematics object are numbers, and the simplest of nature's patterns are numerical. Do we have a number in our environment? Yes, we have, because when we notice the flowers and count them, every petals, we would notice that it has a number and also a pattern. So the next is, what is mathematics? Mathematics has its language. It means mathematical concept, terms, symbols, formulae, and principles. The knowledge of mathematics remains the same in the whole universe. Everywhere and at every time, it is not changeable. Mathematics is an exact science. Its knowledge is always clear, logical, and systematic that may be understood easily. It provides a clear and exact response like yes or no, right or wrong. It is a science of logical reasoning. It involves inductive and deductive reasoning and can generalize any proposition universally. Mathematical knowledge is developed by our sense organs, therefore, it is exact and reliable. So now, we know that mathematics is a universal language, and some of us know that this is the hardest subject and the most boring in the other people. But if we learn and find it interesting, it will challenge of our life, and it will expand our knowledge. I have also heard that the mathematics is craft of creating new knowledge from old, using deductive logic and abstraction. Mathematics is a study of quantity, a discipline that includes the natural numbers and a plane and solid geometry. We find it so challenging and learn the importance of maths in our daily life. Every movement of the person and the falling leaves of the tree, we count it sometimes when we feel bored. And for me, mathematics is the art. Why? Because we draw or any kinds we do is an art of mathematics. The study of ideas that can be handled as if they were real things.
Good day, I am Princess Alhamsi Diego and I'm going to explain what do mathematicians do. Mathematicians use advanced mathematics and technology to study and develop new mathematical principles, understand relationships between existing principles, and solve real-world problems. So what exactly do mathematicians do? Mathematicians are the ones who develop new theories, concepts, or ideas about math. They studied or researched mathematics and they use advanced technologies to create their inventions, to understand or recognize the relationship between mathematical principles and develop new principles to expand mathematical knowledge. Mathematicians are well known for their academic work, but they also do a variety of other things. Mathematicians can solve astronomy, economic, engineering, scientific, and physics or business problems. For example, using probability and statistics, mathematicians can estimate the death tolls from earthquakes and other natural disasters. So mathematic work is divided into two categories: the theoretical mathematics or the pure math and applied mathematics, meaning we have theoretical and applied mathematicians. So what is theoretical mathematicians? Theoretical mathematicians advance mathematical knowledge by developing principles and identify unexplained issues and seek to resolve them. Although they often strive to increase fundamental knowledge without considering its practical use, the knowledge they develop has been an important part of many achievements. So meaning, the theoretical mathematicians create new principles and expand basic mathematical knowledge, despite the fact that they strive to increase basic knowledge without regard for its practical use or application. The knowledge they develop has been an important part of many scientific and engineering achievements, while applied mathematicians use theories and techniques such as mathematical modeling to formulate and solve practical problems in business, government, life, or problems which arise in various areas. So, applied mathematicians solve practical problems by applying theories and techniques. They also tries or attempts to model, predict, and explain things in the real world.
So the next topic is about the nature of mathematics. So, is math created or invented? The mathematics already exists when the people didn't. In ancient times, mankind debated whether mathematics is invented or developed. Did we invented mathematics to surround us in the whole universe, or is the mathematics are only a universal language whether we find it true or not? Like for example is the polygons, equations, radicals, numbers, and etc. are truly real. The independent reality of math is Asian category. Didn't you know that in the ancient they called number 1 as monad, the generator of all other numbers can source that all created were active agent in nature. Plato or the mathematical concept was concrete. Euclid was the father of geometry and he said that the nature of itself are physically manifestation of mathematics. Others argue that mathematics numbers are made or may exist or not. That some believe that our mathematics are human created. Mathematics is an invented logic exercises with no existence, mankind's conscious thought. Language of abstract relationship based on patterns discerned by brains guilty that are useful. But some of the famous professor in 19th century, he said that God created the natural numbers, all else the works of men. But some of the professors said logic mathematics a proposition that assume without proof for the sake of studying the consequence that follows from it. But for me, that mathematics is real, but the hardest part to answer is, it is discovered or invented because it has the deepest answer that until now it's hard to know.
Is mathematics invented or created? So mathematics is invented. It is a product of the human mind, and we make mathematics as we go to suit our needs or purposes. Mathematics was invented by humans. When we say invented, it's an invention, and created, it's an creation. So people often get confused with the words creation and invention. In creation, for example, Leonardo da Vinci masterpiece or work of arts, it is classified as creation rather than an invention because it was unique and could not be replicated by others. On the other hand, something completely new and useful to mankind is referred to as invention, like televisions, telephone, computer. So the people who created those products are known as inventors because they come up with an innovative idea in their mind and translate it into reality that is something useful or tangible to others, just like mathematics. For example, geometries. They were invented with the intention of solving some problems.
Now let's move on to the aspect and issues. The concept and role of the proof. First of all, what is proof? Okay, so the word proof comes from the Latin probare, or to test. Related modern words are English, which are probe, probation, and probability. In general, proof is the power of testimony to prove facts when given by persons of reputation or status. Now let's move on to the concept of the proof. The concept of proof is formalized in the field of mathematical logic. A formal proof is written in a formal language instead of natural language. Meaning, of what we mean formal language mean a formulated language we use when proving a mathematical logic. A formal proof is a sequence of formulas in a formal language, starting with an assumption, and with each subsequent formula a logical consequences of the preceding ones. This definition makes the concept of proof amenable to study. Indeed, the field of proof theory studies formal proofs and their properties. The most famous and surprising being that almost all axiomatic systems can generate certain undecidable statements not provable within the system. Okay, so the definition of a formal proof is intended to capture the concept of proofs as written in the practice of mathematics. The soundness of this definition amounts to the belief that a published proof can, in principle, be converted into a formal proof. However, outside the field of automated proof assistance, this is rarely done in practice, meaning hindi ho ito siya madali because maski practice ay hindi as in ginagawa ito sa ating mathematical system. A classic question in philosophy asks whether mathematical proofs are analytic or synthetic. Who introduced the analytic-synthetic distinction believed mathematical proofs are synthetic, wherein Quinn argued in his 1951 The Two Dogmas of Empiricism that such a distinction is untenable. So most of the steps of a mathematical proof are applications of the elementary rules of logic. This is a slight oversimplification as there are great many proof techniques that have been developed over the past 2 centuries. These include proof by mathematical induction, proof by contradiction, proof by exhaustion, proof by enumeration, and many others. But they are all built on one simple rule, modus ponens ponens. This rule of logic says that if we know that A implies B, and if we know A, then we may conclude B. Thus, a proof is a sequence of steps linked together by modus ponens ponens. It is really an elegant and powerful system. In Occam's razor term, that the word theorem derives from the Greek theoren, meaning to look at. Okay, so one of the most important proof techniques in mathematics is proof of contradiction. With this methodology, in advance that the desired result is false and shows that the leads on untenable position. But in fact, proof by contradiction is nothing other than a reformulation of modus ponendo ponens, meaning wala na ho ito ang proof by contradiction is none other than pag-reformulate or pagbabago lamang ng modus ponendo ponens o ang pagpapagod ng formula or ng ways on how to prove mathematical logic. So what is the role of the proof? The history of mathematical proof in point of fact, the history of the proof concept is rather inchoate. It is unclear just when mathematicians and philosophers conceived of the notion that mathematical assertions required justifications. Meaning, since din talaga unclear na sa mga mathematicians pala and philosophers kung bakit kailangan pa nilang magkaroon ng mathematical proof just to justify one's equation. This was quite a new idea. Then it was another unconsiderable leap to devise methods for constructing such a justification. In the present section, we shall outline what little is known about the development of the proof concept. Perhaps the first mathematical proof in recorded history is due to the Babylonians, meaning ang in record of the history, ang Babylonians pa rin talaga ang pinakauna na gumamit ng tinatawag natin pagpo-proof sa isang mathematical equation or mathematical logic. So they seem, along with the Chinese, to have been aware of the Pythagorean theorem, discussed in detail below, where well before Pythagoras, that the Babylonians had certain diagrams that indicate why the Pythagorean theorem is true. And tablets have been found to validate this fact. So meaning, doon sa pagproof pa lang ng mga Pythagoreans that Babylonians are the first to actually use tablets have been found to validate this fact, or meaning to prove the fact that Babylonians have been the first to actually use the proof or use the formula of proving. So in addition, how did proof revolutionized? Mathematical proof was revolutionized by Euclid in 300 BCE or before Common Era, meaning kung ang mga Babylonians are actually the first to actually use the method of proving or the proving in mathematical logic or in mathematical equations. But then Euclid actually revolutionized the mathematical proof. So sino nga ba si Euclid? Siya yung nag-introduce ng axiomatic method natin, which are still in use today. So, it starts with undefined terms and axioms, propositions concerning the undefined terms, which are assumed to be self-evidently true. Okay? So, meaning itong mga axiomatic method na ito, na applicable ito siya doon sa revolutionize ni Euclid ng ating mathematical proof. From this basis, the method proves theorems using deductive logic. In Euclid's book of The Elements was read by anyone who was considered educated in the West until the middle of the 20th century. In addition to theorems of geometry, such as the Pythagorean theorem, the Elements also covers the number theory, including a proof that the square root of 2 is irrational, and a proof that there are infinitely many prime numbers. So those, so kabilang pala sa book ni Euclid na The Elements, na there are many proof that are there are many equations that were proved in that certain equation. Example are the square root of 2 is irrational, and proving that there are infinitely many prime numbers.
Assalamualaikum and good day everyone. I am Muhammad Elasim Ali Nasser, and the subtopic I am going to discuss is about the infallibility and certainty of mathematics. Infallibility, the traditional absolutist view is that mathematics provides infallible certainty that is both objective and universal. According to this view, mathematical knowledge is absolutely and eternally true and infallible, independent of humanity at all times and places in all possible universes. 150 years ago, on July 18, 1870, the Constitution Pastor Aeternus, which defined the two dogmas of the primacy of the Pope and Papal infallibility, was promulgated. Okay, so when was infallibility used? So, the idea of papal infallibility arises in the 13th century in the context of increasing Franciscan influence at the papal curia. Pope Nicholas III had approved the idea of apostolic poverty and arranged for the papacy to own all the uh, Franciscans well to allow them to live in poverty. The quality of being infallible or of being absolutely trustworthy, he believed in the infallibility of his leadership. Roman Catholic Church, immunity from fallacy or liability to error in expounding matters of faith or morals by virtue of the promise made by Christ to the Church, papal infallibility. Certainty, it argues that mathematical knowledge does not constitute objective truth that is valid for all possible knowers and all possible places and times. In this tradition, the certainty of mathematical knowledge is acknowledged, but the concept of certainty is circumscribed and limited to human knowing. Examples of certainty include the need to meet customer, contract, or regulatory requirements. The outcomes are known to you should you fail to comply.
So that's it, everyone. Thank you for listening to our discussion. And we thank you, Sir Rodney Ligaray, for teaching us this first semester. Again, we are the Group 5. I am Monica Matthew Alcuevas, Group 5's leader, thanking each and every one of you for listening to our discussion.